Now that we have talked about the basics of heat, temperature and units and scales related to temperature, we can start the topic on thermal expansion. Basically, in thermal properties of matter, these are basically the properties which we are mainly going to deal in this chapter. So, what can you think about knowing the name thermal expansion? Thermal means something related to heat. Expansion means something which expands or something which increases in its size, right? So thermal expansion is nothing but the phenomenon of increase in dimensions of a body due to increase in its temperature. So as the name suggests, thermal is heat or temperature, expansion is increase in size of a body. So increase in the size of an object due to increase in temperature. For example, if you heat a particular object, it starts increasing in size. So that is known as thermal expansion. That is, the expansion is taking place due to heat, due to application of heat. Now the next question is, what causes thermal expansion? Why is it that if you heat an object, it will expand? What causes it to expand? Well, now think of a scenario. When I talk of an object, any object in this universe is nothing but matter, right? Now matter in turn is made up of molecules, which in turn are made up of atoms, right? So what happens is, when you heat an object, the molecules inside that object, they are set in random motion. The molecules start moving here and there. They start vibrating. Now, as a result, what happens is, the molecules tend to keep larger distance from each other. I mean, you think of this scenario in this way. Let us suppose there is a certain object which is made up of molecules. Let us suppose initially the molecules are arranged in this way. Now you heat this substance, and what happens? The molecules start moving randomly here and there. So here, if you see, even though the number of molecules will remain the same, even now the number of molecules will be the same, but since they are moving randomly here and there, they are not placed orderly one after the another. So they are randomly moving here and there. As a result, they are keeping greater average distance with each other. As a result, when you see that entire object as a whole, it seems to you, here if you see, this was your object. But here if you see, this is your object. So what do you feel? You feel as if the object expanded, the object increased in its size. So very simple answer is, when heated, particles get random and thus usually maintain a greater average separation. I hope it is clear to you. As I said, when we heat a substance, it expands. Similarly, if we cool a substance, it tends to contract. That is, a substance generally tends to decrease in size when it is cooled. So contraction of substances on cooling is referred to as negative thermal expansion. Thermal contraction is generally not used for this, because many people have this thing in their mind that if for expanding it is expansion, then for contracting it should be contraction. But in terms of physics, mostly we refer it as thermal expansion and negative thermal expansion. When I say negative thermal expansion, I mean I am talking about the scenario where a substance is cooled and as a result it is contracting. So that is called negative thermal expansion. Let us look at certain examples of thermal expansion. As I told you, thermal expansion is all about increase in size of an object when it is heated. That is, when the temperature increases, the size of the object also increases. Now let us look at thermal expansion in case of solids. Most substances expand on heating and contract on cooling. However, there are exceptions. And the most important exception is water. We will discuss about water in a separate slide later. Let us consider solids first. You would have seen that while welding of metals or while constructing some furnitures or something made up of, or some machinery parts made up of metals, what happens is, let us suppose you have a small ring, somewhat like this. This is a ring, and in this ring you have to fit this circular metal plate. Now if you see this, you can very easily say that this plate cannot fit inside this ring because it is very small. So how do we fit it? We heat this ring so that it expands. Once it expands, we just fit the plate inside the ring, and after some time it again cools down. The temperature cools down and it comes back to its original size. But by that time, so what is the advantage of fitting it in this way? The metal plate gets very tightly fitted inside the ring so that there is no chance of coming it out. Now, somewhat like this. Similarly, let us consider the case for liquids. You take some water in a beaker. Place the thermometer inside the water to read the temperature. You will see that once you heat the water, the level of the water increases. But as the temperature reading on the thermometer increases, the level of the water also increases. That is, water expands on heating. I mean, there is expansion with rising temperature. Similarly, in case of gases, you would see that if you place a bottle with a balloon tightly fitted on its mouth, keep it over a frying pan and then heat it. What happens? You'll see that as it is heated, the balloon inflates. Now this inflation of the balloon is because of the heat. Because of this heat, the temperature increases, because of which the size of the balloon increases. That means even through gases also expand when heated. So we saw solids expand when heated, liquids expand when heated, as well as gases expand when heated. Just have a review. This is how the ring is expanded. Similarly, the balloon inflates as it is heated, right? Now we'll go ahead and look at different types of thermal expansion. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you.